What would I do without you?
And just not do your things.
That's right. Okay. So we're gonna do confidence intervals today, but for two samples. So the difference, we're gonna be doing, it's always like the difference between two samples. So like today, this example is gonna be about prom. And what's the difference between the percent of juniors who are attending prom and the percent of seniors who are attending prom? Okay, and so what we've got is, yeah, student council at a large high school, juniors and seniors attending prom. They did a sample of 50 juniors and found that 28 out of 50 are doing it. So that is our proportion of juniors, 28 out of 50, which I will tell you is 0.56. So 56%. And they did a random sample of 45 seniors, and 29 out of 45, which is something like 64.64. So 64% of seniors planning on attending prom. All right. Construct and interpret a 95% confidence interval for the difference in the proportion of juniors and seniors who plan to attend prom. All right. So what is the difference between juniors and seniors planning on attending prom? So we're just going to get what that is. So 0.56 minus 0.64 is a negative 0.08. Because we did junior minus senior. So all that means, just like interpreting that negative number, juniors minus seniors, that just means that the senior number was bigger, which we can obviously see. So it's negative, so that just means senior, right now it means like seniors, oops, that's an M, seniors, senior, and that's not even an R, that looks like, all right, seniors, more, I didn't give myself any room, likely, wow, seniors or Lily. Okay. So that's just what that means, by 8%. So like just from our sample, it looks like seniors are more likely by 8%. But what we're going to do is we're going to construct an interval. So give ourselves, considering some standard deviations, like what is the interval that we think. So right now it looks like seniors are more likely. Does our confidence interval prove that they are more likely? Okay, so on your paper, it looks like I'm going to combine number 2, 3, and 4 into one thing here. It's basically our conditions. So check our 3 conditions. And so what you need to do is you actually have to check the 3 conditions for both juniors and for seniors. So I'm going to like kind of split it. Yeah, okay. So did we do a random sample of both juniors and seniors? That would just be check. Like yes, it said a random sample of 50 and a random sample of 45. Yep. Okay, is a sample size of 50 juniors less than 10% of all juniors? The key on this one is up here it says a large high school. So like Bryan High probably has more than 500 juniors. It's probably close. It's probably something like 520. But we're going to say yes. We're going to say check there. Like it's a large high school. So that's what they were trying to imply, that this was going to be true. And is 45 less than 10% of all the seniors? How many seniors do y'all have? Y'all have But okay, so that's a check, for us too. Okay, so there's more than 450. So we have independent samples in that case. All right, and then this last one is, do we have a normal distribution? So we have to check these three things. And the way you check that for proportions is you do sample size times the proportion. Was it 56? Yep. And then sample size times 1 minus. And those need to be bigger than or equal to 10. Which by my calculation was 28 and 22. Alright, and then the other one, 45 times 64%, 45 times 36%. I don't think I got the right numbers here. I need to redo this on my own calculator. 45 times 64, 28.8. So 28.8, which would mean 16.2. So yes, they're normal. So we can use our z-score can do it. Alright, so our conditions are met. Like, we're not biased, we're independent samples, and I've got a normal distribution. So check, check, check. Good. Alright. So on this, construct 95% confidence interval for the difference. It's kind of a tight little area on your notes, but construct it. So our formula in basic form of it is like point estimate, like your sample guess plus or minus the margin of error. And so in the formula part of this, it's going to be, our point estimate was the P1 minus P2. That was like our sample proportion difference. And then we're going to plus or minus margin of error, which is critical value, z-score, times the, I'll write it up here and then I'll write the formula. So times the standard error. And so on your formula sheet, on the back side, for two proportions, two populations, it's got a formula for us that we just need to be able to plug into. And it says this, it says P1 hat 1 minus P1 hat over sample size of 1 plus, we never minus standard deviations, plus P2 hat 1 minus P2 over sample size of 2. All right, and just for a reminder for y'all, and then just going over it for the at-home people as well. So the big thing with the z-score, so a z-score for a 95% confidence. So the way the table works, or what a 95% confidence, that means we want the middle 95%, and the z-table is limited to all the values less than. So I need to add in whatever percent this part is. And so 95% has 5% on the edges, so that it's evenly distributed as 2.5%. So we're looking up the decimal 9.9750. And when you look that up on the table, that is z equals 1.96, like on the chart, on the z table. So z equals 1.96. So what I'm going to plug in is 1.96 times the square root of, let's see. So then it's just making sure, plug in these formulas correctly, get your numbers correct. So 0.56, 56% times 1 minus it over a sample size of 50 plus 64% times 36% over a sample size of 45. It was 45, right? Okay. Did I do a different problem? Because, like, am I looking at it from y'all's? Did y'all say 70? Why did I guess the problem I had, at the top of y'all's page, does it say a sample of 45 or 70?
44.
Okay. I have the wrong paper. I must have had mine. Okay. Silly me. Okay. 1.96 times the square root of 0.56. 450 plus. All right. I got on the calculator margin of error 0.1964, so I'll just do 196. That is my margin of error. So I need to plus or minus that much from our p hat was negative 0.08. So I need to plus and minus that value. So maybe I'll go ahead and I'll write that in my like little parentheses. So I'm going to do negative plus negative minus, so negative 0.08. Oops. Then do negative. Negative plus. Alright. Let's see. I got negative 0.276 and then a positive 0.116 as my interval. All right, so let's think about like what does this mean? So let's go back to what I did up here. So like this negative 0.08 meant the seniors were more likely to go to prom by 8%. So like what does this interval, maybe let me just go to a new page. What was it? 0.2 something? 276. Okay, so what do those two values mean? So like, let's take this value for instance. What does that mean in context to our problem? Yeah, that means when I do, all these values are doing juniors minus seniors. So this means like seniors more likely to go to prom by 27.6%. That's what that means. But then what does this one mean? A positive number. Yeah, so if I do juniors minus seniors and it's a positive number, that means that juniors are more likely to go more likely by 11.6%. So our interval, what our interval is really saying is we're 95% confident that the interval from seniors more likely by 27% to juniors more likely to 11% has the actual difference between them. So do we really know, like, on number 4, like, do we actually know, so my paper was the one that was messed up, not yours. Do we actually know, like, who's more likely to go? Like, number 4, do we truly know, do we have convincing evidence on who's gonna be more likely? So our interval, if I go back, this interval says somewhere in here, anywhere, is the actual proportion. It could be at 11%, it could be at 10%, it could be over here at -20, it could be at -8, it could be anywhere within there. So do we have evidence? I would say no. Like, because I have negative and positive, I don't know who's more likely. Seniors could be more likely, juniors could be more likely, so I have no idea who's more likely to go or not. So like on number 4, do we have evidence? I would say not evidence that one grade is more likely to go to prom than another. So like there's no evidence because I had seniors more likely and juniors more likely in my confidence interval. So since I had both of them with like an equal chance of happening, then there's no evidence either way. So even if I had this, like let's say I had -50% to positive 0.0001%. Even if I had this interval, I do not have evidence because my interval is saying the positive number had a chance. Like we're saying it doesn't matter what percent of it was negative. This interval is just somewhere in this interval. And so since I had a positive number, there's not enough evidence. Even if it's the smallest positive number possible, there's still a chance. So, not enough evidence. So basically, with these two proportions, so maybe I'll just like make a note here. So two proportions, like when do you have evidence? You have evidence when both numbers in your interval are like positive or both numbers are negative. Then you have evidence juniors are more likely or seniors are more likely. But if you have like a negative number and a positive number, that means that there's no evidence. Like we don't know where it's at. We don't know who's more likely. So if I have two positive numbers, juniors are more likely. Two negative numbers would have been seniors. This is question mark. We don't know. So like these are kind of tough to interpret sometimes. This is where people can screw up a little bit. It's like it needs to be these to be convincing evidence. Any sort of negative, positive, not enough evidence. Alright. So somewhere in that interval, we think. So then there wasn't enough evidence. Alright, let's do another one. With these, I just want to do, my goal is to do as many problems. Because then they become easy when you just do it. Alright. In the study, okay, I have 150 teachers, random sample of 150, and we did a random sample of 100 nurses. Each person was asked if they have a second job. The results showed that 48 out of 150 teachers and 21 out of 100 nurses had a second job. Construct and interpret 95% confidence interval for the difference in teachers and nurses. So with second job. Okay. So like this first part is just like what are we actually going for here? The parameter. And what we're going for is like we want to know the actual difference in teachers and nurses with a second job. So like what that is we really want to know the proportion of teachers minus the proportion of nurses. Like what is that number? The proportion teachers minus proportion nurses. Okay. So 95% affects our Z, so that's going to give us our Z score. We're not worrying about the name of it right now. Don't need to worry about it. Just check our conditions. So 1, 2, 3. So like you could say like, did we do a random sample? And you could say like, check for teachers, check for nurses, because it said random. Okay. Is 150 teachers less than 10% of all teachers? That'd be a check. $100 less than 10% of all nurses? Check. Because it didn't say like in a city or anything, it just, they must be doing it for the entire world, country, whatever, so. Okay, and then number 3, is it normal? So, maybe I need to get the proportion. So, I'm going to do my sample size of teachers times, so let me go ahead and write down my p hat for teachers is 48 over 150, which I got 32%, 32. And the proportion, sample proportion for nurses, 21%, 21 over 100. 0.21. Just shout at me if you need it. Okay. 30% of 150 is already like
48.
Yeah, so it's really high. Check. Like we're way higher than 10. 100 times 21%, I know that one, is 21. 100 times 79%, 79. So those are definitely checks. Like big enough. For sure. Alright. So we have an unbiased sample, so I can talk about this for the population. I have independent samples and it's normally distributed. Alright, so then we finally get to do our thing here. So maybe I'm not going to write the formula. So let's do, I'm going to do teachers minus nurses. So like point that out. So I'm going to do, what was that, 30 something, 32? 32 minus 21 is my p hat difference, my sample difference. And then I need to plus and minus my margin of error. So z-score times standard error. So 95% is drilling into our brain slowly at 1.96. Just think about it in the middle of the night. That's what I dream about. Love it. I don't have enough room here. Then I need to do my standard deviation. 0.32, 0.68 over 150. So here's another spot where people screw up, is like the sample size difference. Because like this one over here is 21 times 79 over 100. So just get those right. So put that in the calculator, 0.109, hopefully, something like that, maybe. So that's my plus or minus margin of error. And the difference initially was teachers in our sample were 11% higher, just in our sample. And so then we need to plus or minus, so then that gives us an interval. Let's see if I can do some mental math in my head. Is that 0, 0, 1? Is that right? 0, yep, okay. Positive 0.01 to 0.21. So before we conclude, like, think about what these numbers mean. This number means teachers are more likely to have a second job than nurses by 0.1%, and teachers are more likely to have a second job than nurses by 21.9%. So do we think teachers are more likely? It would be yes. We're 95% confident. So that's what I can conclude. I can say we are 95% confident. So like there's a chance I'm wrong, 5% in the long run, but we're 95% confident that teachers are more likely to have a second job. My grammar's not right. We're more than the teachers are more likely to have a second job. How do I say by nurses over nurses? Whatever. I'm not worried about. Why would I be worried about grammar now? It's too late in the year. Too late in my life. Okay. The nurses by, and you can say the decimal or the percent. So by 0.01, or you could have said like 0.1% to 0.219, 21.9%. So like this does provide convincing evidence that teachers are more likely to have a second job than nurses. Maybe not by a very high percent. It could be 0.1%, but they are more likely. So we can conclude that it's true. Okay, so it's like the same process, except you've got your subtractions, and then you've got a bigger standard error, and then this interpretation is different. Like, what does that actually mean for the difference?
I asked him for a pass, but he's giving me that.
Lies, policeman. I don't believe them. Okay. Oh, sorry. Sorry, Reagan. Okay. All right. On video. All right. Sweet. So there is a worksheet that you haven't gotten yet. Oops. So how much time do we have? full 30 minutes, 25 minutes. We're doing great. Okay, there's 2 questions here, a front and a back, where you got 2 more problems to work on it. And then on Friday, there's going to be a little test. So we'll go from there. All right. Thanks, Alethea. I know.